So this is question 2A of the 2017 Probability Concepts Practice Exam for Level 3. And this is the NZAMP task, and it's the one we did in Term 3. So, question 2. A study is made of the patients in a hospital during a 3-month period from 1st June to 31st August 2016. There are 214 patients, of which 110 have surgery while at the hospital. Of the 112 who are aged 65 or more, 64 did not have surgery. What is the probability that a randomly chosen patient was aged under 65 and had surgery? Okay, so we need to decide which probability diagram is going to be most useful for representing this information. So let's go to our flow diagram. So here we are. The first thing we need to decide is, are there 2 category variables or 3 category variables? So a category variable, remember, is where you put something into categories. Like gender is a category variable, male and female. Your year level at school is a category variable. So whether you're in year 9, 10, 11, 12 or 13 is one category variable. It may have 5 categories in it, but it's still one variable, year level. So I want you to pause this video and read the question again and see if you can spot how many category variables are in this question. Hopefully you got 2. Okay, so old and young is one category variable. Surgery and not surgery is the other category variable. Okay, so basically it's surgery versus not surgery and old versus young. Okay, so let's go back to our diagram. So that means that we are here, and so we're either going to be using a two-way table or a tree diagram. Now, which one's easier? Well, I think most people find a two-way table easier. So if you can do a two-way table easily, then you're going to. Okay, the way we can tell is if all the numbers provided are counts or proportions but of the total, then it means we can use a two-way table. If, however, some numbers provided are conditional probabilities, that means proportions of a subgroup, then we have to use a tree. Well, then it's much easier to use a tree diagram than a table. Okay, so let's have a look. Now, in this question, are any of these conditional probabilities? Well, no. In fact, they're not even probabilities. They're all just counts. 214 patients, 110 have surgery, 112 age 65 or more. So they're all counts. Therefore, so we can use a two-way table. Okay, so let's draw one up. So we're going to have surgery versus not surgery and old versus young. Okay, so there are 214 patients in total. So what I'd like you to do now is pause the video and copy and complete this table, please, and see if you can answer question part 1. Okay. So these are all the numbers given in the question. Let's see if we can fill in the rest. Okay, so hopefully you got the same thing as me. Right, so the probability that a randomly chosen patient was aged under 65 and had surgery. What I'm going to do is put out of 214 because it's out of the whole lot, and it's going to be 62. Surgery and young, so 62 out of 214, and we can make that into a decimal if we want to. We don't have to. And it is 0.2897 to 4SF. Okay, on to the next one. Okay, what's the relative risk of having surgery for patients aged under 65? So having surgery for patients aged under 65 compared to patients aged 65 or more. Okay, so we need to think about this for a sec. What this is really saying is how many times as likely is it that a patient under 65 has surgery compared to 65 or more? So the first thing we need to work out is the risk of having to have surgery among the two age groups. Okay, so the risk of needing surgery for under 65s, another way of saying that is the probability of needing surgery given that you're under 65. Okay, so it's out of those under 65. So where is that on the table? Well, we're only looking at the young group. So we're only looking at these 102 people. So therefore, out of 102, so out of 102, write that first, needing surgery is 62. So it's 62 out of 102. And if we make that into a decimal, we get 0.6078, etc. Now I'm not going to round that just yet because this isn't my final answer. Okay, so that's the risk among the under 65s. So now I'd like you to pause the video and do the same thing for the risk amongst the 65 and overs. So the risk for the 65 and overs is, another way of saying that would be the probability of what? The probability of needing surgery given that you're age 65 plus. So who's it out of? It's out of only the 112 oldies, the 112 people aged 65 plus. So I'll write that first. So out of 112, and it is going to be 48. And so what's that as a decimal? There it is. So 0.428, etc. Alright, so now it says relative risk, and that means how many times is likely. Now, how do we know? It means we're going to have to divide. It means we're going to have to divide one of these numbers by the other one. Now, how do we know which way round they want us to do it? Well, the way to decide is you've got to decide which is the baseline group. And the baseline group is the one that you're comparing it to. So it's compared to patients aged 65 or more. So we're going to call that group the baseline group. And that goes on the bottom. So we're going to go risk amongst under 65s divided by risk amongst 65 pluses. So let's write that down. So risk among under 65s is 0.607, etc. divided by risk among 65 pluses, which is 0.428, etc. And when we divide those, we get 1.418. So then we need to put this in words. What's that saying? And we want to say a sentence like this. So of the patients in this study, because we can't necessarily apply it or extend the findings beyond the study, so of the patients in this study, those aged under 65, that's the first group, are about 1.42 times as likely to have surgery as those aged 65 and older. Okay? And so that the general structure of that sentence is one you can always use with a relative risk question. Always make it clear for a start which group you're applying your findings to, and the safe way is that unless it's a large random sample from a known group, you can really only apply the findings to this particular group. So of the patients in the study, those who are under 65 are about 1.42 times as likely to have surgery as those aged 65 plus. On to part 3. A hospital board member states as a result of this report that in general, patients who are under 65 are more likely to need surgery than patients aged 65 or over. Discuss why the hospital board member should be careful about making this claim from this report. And that gets back to what I was just talking about, doesn't it? Because even though in this study, the risk is greater amongst the younger patients, it seems odd, and you wouldn't necessarily expect that finding to apply beyond the study. Remember, this is just a study done over 2 months, and only in one hospital, and it's only on 214 patients. And when you're dealing with proportions like we are here, you get a lot of variation from one sample to the next just because of random sampling error. So just because of chance, a different sample of 214 patients could have a very different breakdown to the one we see in this table. And then aside from that, we don't know if it's a representative sample of patients. For example, this hospital might specialise in a certain type of treatment. We don't know anything about that, so we can't make any inferences back to the population of all patients in general. So let's write that down. So, key points. We don't have any reason to be confident that this sample of 214 patients taken from one hospital and only in 2 months of the year, 2 months of 1 year, would be in any way representative of patients in general. In another sample, even from the same hospital, there could be completely different proportions of patients needing surgery in each age group. So the proportions having surgery in each age group could change. It could also change at different times of the year and at different hospitals. Okay, so have a read of that. Now you actually only needed one of these points to get the full credit. Here I've put several. I've talked about time of year, which hospital it is, and also sample size, and also about sampling variation. The sampling variation was the key concept you really needed to have here, which is the fact that every sample is going to be different. So in a different sample, even from the same hospital, the proportions in each age group having surgery could change. So we'd have to be very cautious about our findings. But 62 and 48 could both move around quite a bit. Okay, part B. In the same study as in A, it is found that 106 patients have a stay for at least 7 days. So we're throwing in a new variable here, how long they stay. 60 of these patients had surgery, and 40 of these patients were also aged 65 or more. 30 patients are under 65, didn't have surgery, and stayed at least 7 days. What is the probability that a randomly selected patient did not have surgery, was aged under 65, and stayed at least 7 days? So that's our goal, isn't it? Now, because we've now got 3 category variables, we need to think about which diagram is going to be easiest for this question. So if we go back to our flow diagram as a guide, we're going to be doing a 3-way Venn diagram or a tree diagram. Now, we can do a 3-way Venn diagram most easily if all the numbers provided are counts or proportions of the total. Now, in this case, they're all counts, like they're how many, they're not what percentage or what proportion. So therefore, we can use a 3-way Venn diagram. It says here the same study as question A, which suggests what? Well, it suggests that we're going to need to use information from question A as well. Okay, so that's really important to bear in mind. Whenever you do a 3-way Venn diagram question, just always be on the lookout that it might be using information from an earlier question too. So, the 3 categories, 3 category variables. Firstly, it's whether they stay for at least 7 days. So I'm just going to call that L for long, whether they stay for a long time. And so that's my first circle. I make my circles quite big, so I've got heaps of room, so that's L for long. The next category is whether they had surgery, so that's going to be S for surgery. So L and then S. And then the third category is whether they were age 65 or more, and we're going to call that O for old. And actually I might put the word old because the thing is, otherwise it's going to look like a 0, isn't it? And that could get confusing. Okay, now we need to start filling in what we're told. So, 106 patients have a stay of at least 7 days. So that is the long category, so that's the long circle. So that's going to go, because it's the whole circle, I'm going to put it at the top like a heading. So 106, use a different colouring pen. Okay, and 60 of these patients, so it's only of those patients in the long circle, 60 of these patients had surgery. So that's going to be, where's that going to be? Now we have to be careful here. So we need to find the region that is patients that stayed a long time and are in the S circle. So the L circle and the S circle. So it's going to be this whole zone here. Okay, 40 of these patients were also age 65 or more. So what does that mean? It means of those 60 patients, there were 40 age 65 or more. So that's going to go in here, the old circle. So that's actually the overlap of all three circles, isn't it? Okay, so ticking off the information we've ticked off that, and that. Now, 30 patients are under 65 and didn't have surgery and stayed less than 7 days. So where's that, do you think? Well, under 65 means they're not in the old circle. Didn't have surgery means they're not in the S circle. And stayed less than 7 days means they're not in the long circle. So where does that put it? Puts it outside all three circles. So that 30 just goes out here. Okay, so I've now counted that too. Now the question is asking for what? What's the goal? We want to actually shade that in first. So what is the probability that a randomly selected patient did not have surgery, so not in the S circle, was aged under 65, so not in the old circle, and stayed at least 7 days, so they are in the L circle. So the L circle but not S and not old. So that's going to be where? So this zone here, isn't it? So that's the goal we've got to find out. Okay, do we have enough information yet? No, we don't. So we need to go back to the information we got from the first part of the question. So question A. And what we need to do is transfer everything from this two-way table into that three-way Venn diagram. Okay? So what I'd like you to do is I would like you to, if you haven't already, draw up the diagram we've got so far and take the information from the two-way table and see if you can assign it to the right regions, and then have a go at the question yourself. So if you don't play any more of this video and you can get it yourself, then that's great. Maybe just check at the end to see if you got it right. Remember, you won't learn much from watching this as a video or as a movie. You need to have a go at the question yourself. This is just here to help. Okay, so here's the table, pausing the video and seeing what you can do. Okay, so we know that there's 214 total, so I'm going to put that at the top, 214 total. Okay, we also know that there are, what else? There's 112 in the old category, so that means that I can put 112 down here as my old category title, and then 102 outside of that, so that's cool. 110 that had surgery, so 110 goes here, the heading for surgery. What else? We know that 48 were old and had surgery, so the old and the S circles, isn't it? So that's 48, so there must be 8 here. Okay, and what else do we know? Well, we can now work out this region, can't we? So 110 minus 20 minus 40 minus 8, so minus 68, and what's that? 42. Okay, what else do we know? So let's think outside the circle a little bit here. Excuse the pun. What's this 40 going to help us with? Let's think about this 40. Who are these 40? These are the people who... So these are the people who didn't have surgery and are not old. So didn't have surgery and aren't aged over 65. So where's that going to go? So it's these 30 here, plus where are the other 10 going to come from? The other 10 must come from here. So that means we now have our answer, don't we? There must be 10 people that were in the long category, but not in the surgery or the old category. So that was the question. What's the probability a randomly selected patient did not have surgery, was aged under 65 and stayed at least 7 days? So now we can write that down, can't we? So probability not S, no surgery, and aged under 65, and long, meaning at least 7 days, equals, now if I just write 10, would that get marked right? Well, no, it wouldn't. Why would that get marked wrong? Because it's not a probability, and I've seen so many students do this, and it means you do all the hard work and get nothing, or certainly don't get full credit. It's got to be 10 out of, and so out of the whole lot, randomly selected patient, so yeah, it is, so it's 10 out of 214. And if we want to make that a decimal, we don't have to, but 10 divided by 214, and it's 0.0467. It's 3 significant figures. Okay. That's the end of this video. I'll see you later.